Is Geometry, Section 1.1. We're going to begin by talking about the building blocks of geometry. So this chapter we're going to be doing a lot of definitions. So you're going to want to get your pencil ready because you're going to be taking a lot of notes. Okay, let's begin. The three building blocks of geometry are points, lines, and planes. That's on the second page. Planes. Okay, let's define what a point is. Well, it's weird that I've used that term because points, lines, and planes are the three undefined terms in geometry. And the reason that you can't really define them is because they don't really have a size. For instance, a point has no size, it only has a location. It's named with a capital letter. So there's an example of how to name a point. Lines. Straight continuous arrangement of infinitely many points. It has infinite length but no thickness. So again, it's hard to, you can't really come up with a definition of a point and a line because they have no size. Lines are named by giving the letter names of any 2 points on the line. I gotta reposition my paper here, this isn't working. And by placing the line symbol, which is the little line with arrows on both ends above the letters. So in this case, line AB can be named in this manner. So when we look at planes, a plane has length and width, but no thickness. It's a flat surface that extends infinitely along its length and width, and it's represented by a four-sided figure, like this here, with the script capital letter. So this plane is named plane R. This part is really important to understand. Points, lines, and planes are the only undefined terms in geometry because they have no size. Keeping that in mind, we're going to go on to all the things that can be defined. Terms we can define. Collinear means that they are on the same line. So in this example, you can see that A and B are on the same line, so we can say that A and B are collinear. Coplanar means that they are on the same plane. So in this case, A and B are both on the same plane, so A and B are coplanar. A line segment consists of two endpoints and all the collinear points between them. Notice that a line segment has endpoints. In this case, A and B are the endpoints. It does not continue infinitely in both directions, or in either direction. This can be named line segment AB, denoted by just a straight line with no arrows on them, or BA. It doesn't matter which direction you name the line segment. Going on, we use the equal sign, as you know, when we talk about numerical expressions that have the same value. In geometry, we talk about congruency. So this symbol right here with the squiggly line and the equals underneath it means is congruent to. We use that when we talk about geometric figures. When drawing figures, you show congruent segments by making identical markings. For instance, let's look at this figure. Because A and B and D and C both have the same two little hash marks, we know that AB is congruent to DC. And same with AD and BC, because they both have the same number of hashtags. That those two are congruent. AD is congruent to BC. and that's how you denote it in geometry. Midpoint is our next definition. The midpoint of a segment is the point on the segment that is the same distance to the endpoints. In other words, the midpoint bisects. It divides into the line segment. So here we can see that Q is the midpoint because the distance from Q to R is the same as the distance from Q to P. A ray has a starting point and has infinite length in one direction. So the starting point is A, and you can see it goes through B and C and is infinite in that direction. You can either name this by ray AB. Note the symbol here has an arrow only on one end, or you could name it ray AC. Notice how both of these, when you're naming a ray, the first letter has to be the starting point. That was it for 1.1, but I'm going to go ahead and talk about the midpoint because there is a page in your worksheets where you're doing work with finding the midpoint on the coordinate plane. So you're going to want to write down this formula. If x1 and y1 and x2 and y2 are the coordinates of the endpoints of a segment, then the coordinates of the midpoint are as follows. So you would take the two x's divided by 2, that's the x value of the midpoint. The y value of the midpoint is the two y's added together divided by 2. Think of this as the x value is the average of the x's. The y value of the midpoint is the average of the y's. Okay, so let's do an example. Segment AB has endpoints at those two coordinate points. And you're to find the coordinates of the midpoint of AB. Alright, well, I just drew a rough sketch of where that line segment looks. There's A, there's B. So using the midpoint formula, I'm just going to add the x's, negative 8 plus 3 divided by 2, and then the y's, 5 plus negative 6 divided by 2. Negative 8 plus 3 is negative 5 divided by 2. 5 plus negative 6 is negative 1, so it would be negative 1/2. And then, as you can see, this is where it would land. Yep, it looks like we did it right because that does look like the midpoint. And that covers 1.1 and your sheet on finding the midpoint.